everyone, how are you all? Welcome back to the Schematic Education. In another new video, I hope all are you good and learn something new with every day. Right? So in this video, we discuss about the power IC, how to diagnose the power IC, how to confirm the power IC faulty or not, the power IC working, repair, testing, solution, all in this video. If you watch this video properly till the end, you will get all your answers related to the power IC. Without skipping, watch it properly. So don't waste any more time. That goes to the video. Let's start the video. Now, a phone comes to you for repair, for fixing in a dead condition. You will find in this phone, suppose a power IC fault. When you diagnose this phone in a proper way, step by step, you will find in this phone there is a power IC faulty. How to confirm is the power IC faulty or not? Right? I will tell you in this video. Now next, suppose you diagnose the power IC and the power IC not generated the buck line outputs or LDO, right? I mean to say, when you measure these bucks on a voltage mode, DC voltage mode with a multimeter, on this bucks you get a variation, a voltage variation. How? I will tell you. Suppose you get sometimes 0.6, sometimes 0.8, again 0.4, 0.2, again 0.6, 0.8. That means these voltage fluctuate when you connect the charger or connect the battery after you measure on these bucks lines, on these bucks a voltage with the multimeter. I hope you get my point. So basically the voltage fluctuate, right? So why this output voltage, or you can say the buck lines voltage, fluctuate? What are the reasons? I will tell you in this video. Now next, suppose these bucks, all these bucks, the output voltage not generated by power IC. So what are the conditions? All the questions in your mind about the power IC output lines. So we discuss about this power IC in this power section, a power chip. How this power chip working or generate output line. How to test this chip is faulty or okay, right? Now power IC has many sections. I will show you. So first layout, and this is our power IC. Just copy and paste in schematics. And next, so this is our power IC MT6358, and this is our blocks. On the last you will see A denote there are many blocks in this IC, many sections. What are the sections? For this we just click next. Now A to B. Again I will show you A. Now this section belong to the buck section. All the bucks detail, how the buck section working, a sequence, right? All the buck details. Now second, after this you will see in this section, you will see the LDOs, right? Got that? Now after, in a third section, you will see a charging pump or gauge section, a charging, right? Not a charging section, charging sense related section, also a gauge section. Now what is gauge section and how the charging sections, these sections work, I'm already explained in the previous videos. If you don't know about these sections, how these sections work, give you all detail in a deep knowledge in a previous videos. Go and check out the previous videos. Now there is a C section, you can say controlling section, controlling pins or protocols, right? Now after that D, there is a audio, now aux, now there is a crystal, related, and after the controlling section, some sensors. So you can say there is many sections, almost 7 to 8 blocks, right? The power IC. In a one video, we did not cover all these sections because I'm explaining in a detail, right? So on my topic, I did not cover in a one video all the blocks, or you can say all the section about power IC output or input. So in this video, we discuss only first part, the buck section, how the buck section work, buck variation, I mean to say buck fluctuate, how to measure a buck short or not, right? Many technicians confuse, or you can say did not understand this section. So I will tell you in this video about this section. Now let's go to the motherboard first. If you look at any mobile PCB, you will see some big inductor near the power IC. These inductors we call coil or inductor or coil. Other name is a coil. Now look at the second board, another board. Now this is a Samsung. You will see a power IC, power S537, right? Near the power IC, you will see there is also a buck inductors. We call buck lines, or you can say buck section. Whether it is single power IC phone or dual power IC or triple power IC, latest 5G phones with a 4 power IC, you will see all the power ICs near, you can say, multiple inductor or coil, right? We call a buck lines, or you can say buck coils, a buck inductor. Now, in some phones, you get 5 to 6 buck coils. In some phone, you get 7 to 9. In multiple power related phones, right, which had 2 powers, 3 powers, 4 powers, you get 20 plus buck coils. I mean to say buck line. I hope you get my point, what I'm saying to you. Now, how these buck lines working, I mean to say inductor. Also one thing, you will see similar inductors in a PCB in other sections, like near the DC to DC coil, you will see these are the similar bucks, right? Near the DC to DC IC, also graphic IC, audio IC, and the light IC. Sometimes its shape different, but sometimes you will see the similar. So what are the differences? These coils, basically, for example, in a light section, you will see a boost coil, and this is a buck coil. So what is the difference, and what is the inductor? I will explain to you first. Before going to the power IC section, I will explain to you how the buck section work. First, we will understand what is inductor, and what is the difference between buck coil and a boost coil. Now, I'm not giving you too much detail on a buck sections, I mean to say these inductor, because this section belong to the basic electronics. I'm only giving you a necessary information so you can easily understand the power ICs. If I'll give you a full detail about the inductor, how the inductor work according to the basic electronics, right, with examples, with the details, for this it's need a separate video. It's a long topic, so we give you a little bit necessary information so you can understand the easily this concept. So let's start. For this, I will show you inductor and coil. I'm not talking about the other electronics. Most probably you will see these type of coils in electronic devices, but mobile phones, you will see these type of the inductors. Also this type of many type of the inductors, a small, also a big size. For example, I'll show you a 2 inductors. Now what is inductor? First, inductor is a electronic component uses in an electronic circuit for store the energy. Capacitors also store the energy, but this inductor or coil store energy in a magnetic field, right? I will explain to you. Suppose when a voltage passes this buck line, this will store energy around a magnetic field like this. Clear? Inductors is working like a magnet because when voltage passes, it's work like a electronic magnet, store energy in a magnetic field. That's why it's working like a magnet, right? It's uses for the maintain the current ampere, right? Now how this inductor made? A plain copper wire. Inductor made with a plain copper wire. When you turn around, or you can say this coil wrap around a core material like this, and this copper wire a insulation. This is an insulation wire. So when you wrap around a core material, so we call this is a coil. This is a basic information, not in detail, because in a further we discuss about the power section. So already my videos are very lengthy. In a basic information, unnecessary information. Basically the copper wire, insulated wire used as a inductor to wrap around a core material. Now let's get back to the mobile phone PCB. In a power section, in a network section, you will see these type of these RF inductors, but I'm talking to the power sections, right? In a power section, you will see two type of coil with the different shapes, right? First one buck and second boost, right? You will see these buck coils near the power IC. I'm already shown to you in a motherboard, right? The boost coil you will see near the light IC, also the graphic IC. Now what are the differences of boost coil and the buck coil? I will explain to you. Now let's first talking about the buck coil. Buck coil you will see near the power IC, a PM chip, right? The buck coil made with the thick wire like this, the thick wire around, right? So buck coil uses for decrease the voltage and increase the current ampere. That's why it's uses in a power section near the power IC, or you can say in between power chip and a CPU or master IC, CPU core voltages, because CPU need low voltage, high ampere. Clear? That's why the buck coils uses in a connecting between power chip and the CPU, right? Now buck coils made with a thick wire. Clear? Now on the other hand, the boost coil made with a thin wire, but the turns will be more, right? You will see there is a less turn, there will be a more turns around the material. Now boost coil uses for the boost the voltages. That means it produce with the circuit high volt. You will already see in a light sections when a boost coil with a circuit create 3.7 voltage convert to 15 volt to 40 volt with the help of boost coil. The IC, the diode and the boost coil working together with a capacitor after the voltage increase, but the major role in between the boost coil. I hope you get the differences between buck and boost. What are the difference between buck and boost? A simple thinking, the number of turns made with thick wire, also the number of turns will be less in a buck coil, a number of turns will be more in a boost coil with a thin wire. Boost coil uses for high voltage, buck coil uses for high ampere, low voltage. Now let's go to the power IC, our main topic, and I will explain to you how the buck section works, because many technicians did not understand this section clearly. They were confused. Suppose a phone come to any technician on the testing time, they get confused of this buck coil, any buck coil with a low value, or this is a short or not, because if you use a normal multimeter which had continuity mode, a beep mode, or you can say diode mode in a together, the multimeter beeps on a coil, and some technicians think this is a short and they inject the voltage on it. After that, the CPU, your master IC, will be gone forever. This is a big mistake of fresher students, or you can say a newbie or freshers, mostly doing these type of mistakes when they don't have any knowledge about this section. So I'll give you a knowledge about this section, how the buck section work, how the boost sequence, or you can say buck sequence work. Everything in a detail. My English is not good. This is not an English teaching class. I hope you get my point. You will understand what I'm saying to you. Only that matter you can understand the topic. Now, before going to the power IC, I will show you a small circuit. So, who don't know about how the circuit work, how the power IC input, they will know these things, get information, a little bit information before going to the power IC output lines, right? So first clear it. Now you will see in front of you there is a circuit. So who don't know about anything, first of all, they watch my video in a first time. If you don't know about this circuit, how the charging circuit work, what are the charging or DC to DC IC work, how the power IC input requirement, all these things, if you don't know, check out my previous videos from lesson 1 to our latest video, this one by one. You get good information, or you can say a good detail about how the mobile, or you can say phone circuits work. Let's start with this. When you connect a charger, a line goes to the DC to DC IC, or you can say our charging IC, right? We call V pass line. In this line, we get a 5 volt, right? Also, when you connect the battery, or you can say in latest phones, connect battery already connected, or you can say when you remove the charger, a battery voltage goes to the DC to DC. In this line, you get 3.7 to 4.2 volt a battery voltage. Clear? After the charging chip, also called DC to DC IC, process this voltage and create another voltage called VPH, also a V system, right? In this line, you will get 3.7 to 4.2 volt. Now this line goes to the many sections like network, audio, light, right? All of the sections, Wi-Fi, Bluetooth. Also, this voltage goes to the power chip for the voltage requirement of the power IC, or you can say fulfill the voltage requirement of the power IC with the many ways. I will show you all these detail in this video. Right, after the power IC generate some voltages, we call buck and LDO voltages, communicate with the CPU. Basically requirement the CPU core voltages, also eMMC voltages, RAM voltages. After your phone processing work, or you can say your phone turning on. So this is a basic structure. If you get more information about this circuit, go and check out my previous videos. Let's talk about this topic, today topic. For this, we're going to the first schematics. For this, we're going to the Borneo, and Borneo, we open the schematics. Let's see. Right. So first, from DC to DC power supply, a voltage come in. We call V system, because this is a MediaTek phone. So in MediaTek, we say V system. In a Qualcomm, we say VPH. One thing clear? Now this voltage, this line, in this line you will get resistance. After this line, with a capacitor, goes to the V system SMPS circuit, right, for activate the SMPS main power supply circuit. After this, now one line goes to the direct to the power IC in SMPS section, but we discuss only the buck section in this video. So another line come here, from this line emerge and go to the VPROC 11, pin number A6 and B6 with the capacitor, right. Also A8, B8, the ground pin, right. Now same line goes to the different ways. I will show you something. Now you will see, first I will move this V system line come here in a A6, B6, and output coil same VPRS OC 11. Now you can see here VPROC 12, in output VPROC 12, a VCORE in, a VCORE out, VMODEM in, VMODEM out, VPA in, VPA out, VSN in, VSN out, VS2 in, VS2 out. That means if there is a 9 coils, right, 9 buck coils in a output section of the power IC, you will see 9 entry point, 9 ways where the V system line enter for each and every bucks, from this way input and through this way out. Clear? So whenever a phone come to you, check, you will see near the power IC the capacitors. In every capacitor you get 3.7 to 4.2 voltage. Just connect a charger, then you can check here voltage. I will show you. You will see main motherboard and the power IC. You will see these capacitors in front of here the buck coils. You will get here a VPH voltages. If there is a 9 buck coils, you will see the 9 capacitor. That means 9 through 9 ways V system enter in a under the power IC, in a power IC. Suppose if there is a 7 buck lines, buck coils through 7 ways, right. I hope you get my point. So in these capacitors you get 3.7 to 4.2 voltage. Now every chip made with a MOSFET. So under the IC, switching create through these buck lines and the output generate. Now how these buck lines, I will explain to you one by one. I hope you will understood what I'm saying to you, what I'm taught to you. Clear? Now get back to the schematic. Now let's start. First, you will see. Now let's understand the buck section or buck sequence with the all details. How the buck comes out. I mean to say which buck line come out first, and after the second, after the third sequence. Right now for processor VPROC, that means voltage for processor. Voltage for processor. There is an input pin number A6 and B6. There is a ground A8 and B8. The outputs merge, or you can say output generated by A7 and B7. Right? In this line, you get one 4.7 microhenry coil, a buck coil. Clear? After this line, in some filter capacitor. Now, where is this line going? Just copy this and next. Now, this line come back to the this IC called voltage for processor FB. Now, what is the meaning of FB? FB means feedback, right? A feedback line from the output. The power IC confirm whether the voltage is correct or not through the feedback. In this line, any short or not, right? A feedback line. Now next. Now this line goes to the another IC. Which IC is this? U1000E MT6769. This is our CPU, right? CPU in voltage for processor 1. Pin number B1, B2, B3, B4, B5, B6. These all are the pins connecting to the first coil. Right? All these the filter caps in this line. Clear? Now next. Now like this. These all are the connecting point. Now this line goes back to the same power IC. That means this line connecting between from power IC and the CPU with the buck coil. Also a feedback line goes back to the power IC, right? Now where is this buck line? Just copy this buck and then lay out in a paste. Next, now this buck from here to 1, 2, 3 in a motherboard. This buck. V0, V voltage for processor 11, 1, right? We're talking about this buck. Now, I will show you this line in a bitmap, right? So you can understand in a better way how this line works. For this, just go to the L2001. Now copy this and paste in layout and find this coil. Where is this location? We will see 1, 2, 3, third number coil. Right? Now just go to the bitmap and see this. Now zoom it. Now coil number third, you will see this. We are talking about this coil. Now when you click on this side, input side, you will see so these two pins are two walls from power IC. This coil connected and switching here. After the switching, on the other hand, this line goes to these capacitors, also get back to the again power IC, power chip, with this port we call a feedback. As I already shown to you in schematics, a feedback line. Also in this line you will see these capacitors. Now this line goes to the CPU in these balls, multiple balls, these green color balls you will see. Now suppose if any one of these board not connected properly for any reason, like waterlogging or drop down or any reason, this not connected, the voltage or the diode value, the connectivity is not here with your CPU. Your CPU does not work. Now first condition. Now I'm telling you, if you check here in this capacitor, you will see the reading is okay. Also, I mean to say diode value in a good condition. Also the voltage is here. But somehow any ball not connected to the CPU in chance, the CPU did not boot and your phone does not work in a dead condition. I hope what I'm saying to you, it's clear to you. Now in this line you will get a low reading, I mean to say low diode value. When you measure in a diode value in a multimeter, also with the in ohms mode, you can see most probably there is sometime of 15. In some lines you get of 15, 20, right, a diode value. So some technician confused. Also, if they used a yellow multimeter or some kind of multimeter with a beep mode or diode mode attached, I mean to say combine your continuity mode and diode mode. With this multimeter, with this kind of multimeter, when they test or on a checking time, when they test on this point in these capacitors, you will see your multimeter on a beep. So according to the multimeter, some technicians think this line is a short, right? So they apply, or you can say they inject the voltage here with the DC power supply, also sometime with a short here, right? When they inject the voltage, no parts will be melt. First condition. Second, for this reason the voltage increase, right? Sometime they increase voltage in a 4 volt, so remove the shorting easily. But in this case, because this supply, or you can say this line directly connected to the CPU, right, your CPU will be gone forever. Now there is no chance to this phone recover, because in this line you will get a 0.6 to 1.2 volt. When you check on a diode mode, you will see sometimes a 15, 20, 25, 35, 40, this kind of reading in some lines for connecting to the CPU, right? If you do not understand the circuit, or if you do not know about the circuit, how the circuit work, how every section or each line working, do not inject any kind of voltage without knowing the line of the details, right? So let's see this in a diagram so you can better understand. For this we make a diagram. In front of you there is a diagram, a power IC, a CPU. How these lines work, I will tell you. Now according to the schematics, from a V system line, a line comes from the DC to DC IC. Now this line going to the direct to the first power IC. I am not making a SMPS line, just only buck lines. So first line goes to the power chip input voltage. After this line generate a voltage, or you can say a buck line with a buck coil called VPU. VPROC1, voltage for processor 11, or you can say 1. We're just talking about this line. In schematics, also I'm showing to you in a bitmap. Right? Now, after this, another line emerged from this line and goes back to the power IC. We call a feedback line. This line called feedback. We see in schematics, right? Now, in this line, you get 0.6 to 1.2 volt. Right? I'm also telling you how to test in a multimeter in a diode mode. If you see any one of line who connected to the CPU through power IC, basically a core voltages or CPU related voltages, you can see 15, 20, somehow 15, 40, 45, 60. Do not think this line is a short, and do not inject any kind of voltages on this line. If you inject in this line thinking this line is short, inject some kind of voltages, your CPU will be gone forever. So in this section, be careful if you use a short killer. Avoid this. If this line had a short, most probably chances any one of these lines, a buck line shorted, if you feel, and if you know, confirm it, this line had a short. 90% chances this line shorting through a CPU, because when in drop down case, your CPU had multiple balls, right? In a drop down case, some balls attach each other. So some ball connecting to the ground. In a drop down case, then these lines had a shorting in a 90% chances. So it's clear to you. Now let's get back to the schematics and see the another lines. Now after this, you will see VPROC 12, voltage for processor 12, another line from V system line, another input line with a capacitor connected to the pin number A10 and B10. Now remember one thing, if this line, or you can say not connected A10 or B10, suppose if you get a diode value here, but somehow you will see this ball connected, but this ball, a carbon or water logging or any reason, this ball does not connect. So VPHs or V system voltage is not there. So this IC not produce a second buck line. So your phone does not work. Or if you did not get voltage on this capacitor, suppose this line is open from here, you can take a jumper from here to put here. If A10 line ball open or B10, both lines are open, you get voltage here. That means there is a connectivity fail. So you can jumper it from B6 or A6 or any nearby ball where is V system connect. Okay. Now after the input a B9 and A9 produce a switching with the L2002 coil. After a produce a line. Now this line is going to the checkout for next. Now a feedback line, right? Pin number EN, E9. I'll show you, right? Now next. Now this line goes to the CPU, VPROC2. So this is our MT6769 SBS R CPU. So in this line, you get some capacitors, right? Also this line connected to the multiple points. As I'm told you, this line connected to the multiple points. If any one of, first I will show you in a bitmap and make a line in a diagram. So after I will explain to you so you can better understand. Let's go to the schematic again. Just next. Now this line connected to the all these balls. Remember one thing. Now we are back to the power IC. Now copy this coil and paste in layout for the location. Now 1, 2, 3, 4. Just go to the bitmap and this one next. Now here is the input from 2 volts, right? Now here is the output. Now this is the feedback line. Clear? We will need this green color ball from here. These 2 volts from here is the input. Clear? And here is the output. Right? Now this line also connected to the some capacitors in nearby. These capacitors directly connected in between a power IC, also a CPU. This line also has a V processor voltage. A multiple wall connected. Same situation or same rules apply here. If any one wall of did not connect to the CPU for any reason, your phone or your CPU does not boot, right? Your phone does not work. Also, same, if any one of these capacitor, you will see a low reading, a low diode value, a low ohm reading. Do not get thinking this line is short. This is a low value reading. This line is a for high ampere low voltage line. In this line you will get a 0.6 to 1.2 voltage sometime, right? Most probably you will get a 0.8 voltage stable in a working condition. So if this line is short, your phone permanently dead. If this line is short, also a open, but never think if you get a reading like 20, 15. So this is not a short. If you use a yellow multimeter, this line get a beep called your multimeter. So most technicians think this line is in a short condition. So they apply a short killer or injective voltage from DC power supply with a short killer. Never do this. Let's make this in a diagram for better understand. Now again a line comes in from a V system, this red color line, another voltage from another input from another voltage. After this a line create and V processor voltage 2 goes to the CPU with a multiple poles connected to the multiple balls. In this line you will get multiple caps. In this line you will get 0.6 to 1.2 volt, right? Get. After this a line goes back to the power IC from here. This line called a feedback line. If this feedback line is open, damaged or short, your phone does not work. Remember this thing also. I hope you will understood how this concept work. Now let's get back to the schematic again for new line. Now another input comes in for the VCORE ball number A15 and B15. Also the ground lines also are important, right? I'm always said the ground lines are also important, right? Now from the output, a VCORE input there. Now after that output from A14 to B14 with the L2003 0.47 microhenry coil is in there. Now this is a core voltage for the CPU. I will tell you again, this is a core voltages for CPU again. When you copy this line again, now there is a feedback line, also a feedback ground. After this line goes to the CPU or core section. Now this line connected to the multiple balls. From here you can see from AD20, AB22, H21, L11, 12, 15, 16, M12. So you can see here also in this line are multiple capacitors. Same rule apply here. If you see a low diode value in this line, do not apply any type of voltages, inject any type of voltages. Also if this line is open or damaged, your phone does not work. Clear? Now let's make a diagram Now after this input line, right, after that input another line created by power IC with this switching with a coil called VCORE, voltage core, for the CPU core voltage basically. After this another line emerge and goes back to the power IC, this line called feedback, right. Now this CPU line connected to the multiple balls. If any ball does not connect, lose, or did not get attached, connectivity, lose connectivity, or open, your CPU does not boot. In that case, you revolve the CPU. In this line, you will get 0.6 to 1.2 volt. Clear? Now next, for this, right, now another input from VMODEM, right, F14 pin, after the output VMODEM. Now in this line you will see a coil, 1 microhenry coil, right. Now this line also goes to the CPU. Just copy this and now feedback line. Now next, now this line also say goes to the CPU in a modem section. Now I will show you in a bitmap also. After that I will explain to you about this line. Now L2004, just paste in layout, just see the manual. This one coil, 1 2 3, third number coil, L2003. So you can see here this coil. So there is an input, right, from coil. From this end you will see the input and the output connectivity, or you can say also a feedback line connected, goes back to the power IC. Also this line connected to the some caps, capacitors, also with the CPU. But there is a catch. Now this line VMODEM, right, basically your CPU had a baseband section. This voltage for the baseband activation, right. In this line you get same 0.6 to 1.2 voltage, right. But if this line damage, if you did not get any voltage on this line or any reading, suppose this line open from the CPU or power IC, in case your phone working very, I mean to say your phone turning on, but there is a no network, no baseband, only a network issue. Clear? A baseband related issues, but your phone working on, right. But if this line any cap or somehow this line short, right, then your phone does not on, then your phone does not work, your phone on a dead condition. Let's make this line in a diagram after some explanation. Now another voltage comes, right, for voltage model. After this CPU power IC generate another voltage, a voltage called VMODEM, direct goes to the CPU in a baseband section. In this line you get 0.6 to 1.2 volt, most probably 0.8 volt. Clear? If this line open, suppose this coil open, you did not get any voltage here, right. Your phone on a on condition, turning on, but there is a baseband related issue, means a network related issue, no service, no network. I hope you will understood this theory. This is only a single power IC lines, right. After that a 2 power 2 PM, are 3 pm power module chips are 4 pms. But I am taught you in a way, in a easiest simple way, so you can easily understand each and every line or testing. So please listen every word of mine careful. When I say to you, do not apply in these lines any kind of short killer. First, your basic strong, your knowledge about circuit strong after you apply any kind of voltages for any line. When you know about the line, why and how this line working. Clear? Because a customer phone relied to you. Maybe a customer give it to phone on a dead condition, but there is a normal problem, a simple problem. Suppose this buck is damaged, so you can replace a buck with the same value or 2-minute work. But when you check any kind of capacitor connected in these lines, you think there is a shorting. When you read a 15-20 reading, also your multimeter beeps. You think this line is short and you inject the voltage. So this phone permanently gone, never repair. So you lose your reputation also, or lose money for a customer. I hope you get my point, what I'm saying to you. Learning strong your basics. Right, now let's get back to I'm not giving you any type of lecture, just care for you. Because in a starting point, I made a lot of mistakes, and no person guide me. But for you, I'm here. I will teach you. So let's back to schematics. Now after the VMODEM line, another input from VPA in. Right? Suppose there is a 9 coils, then there is a 9 input. If there is a 5 coil or 7 coil, there is a 5 or 7 input. If any coil had input not connected, right, the output is not generated. Now for next VPA, another input voltage. For checking, you can check here on this capacitor, 3.7 to 4.2 voltage input line, right? For this, copy this capacitor and find the location easily. Now after this, A4 VPA L2005, another coil, and this line also a feedback line. Now where is this line going? Now this line not connected to the CPU. Just copy this and next. Now this line goes to the, which I say this U3200. Just copy this and paste in layout, and you will see there is a 4GPA. So this voltage for the 4GPA, I will explain to you. Now get back to the power IC again. Now VPA L2005, a feedback line also connected. So let's go to the bitmap map. First we see this coil number, where is the location. So copy this and paste in layout, and next you will see a second number coil. For this, just zoom in a bitmap, and this is there is the input or this coil, and this is the output. A feedback line also this capacitor through this line goes to the directly to the 4GPA, does not connect to the CPU. Clear? So if this line damage or open, your phone still working on. but there is a network issue. But if this line is short, your phone does not work. Clear? Let's make a diagram on it. Another input, a VMODEM feedback is remain. Clear? Now if there is input line, after the VPA line generate. Now this line does not connect to the CPU, right? This voltage only comes after the insert the same. Remember thing. Now after this, another voltage generate. I will explain to you first our VGPU line. I will explain you later. First going back to the CPU. Schematics. Now after this, there is a VSN1 and VSN2, VSN1 and VS2, but we will discuss about later in this video. We will discuss about it, but after these two voltages. So VGPU in, right? The input voltage come here A1 and V1, 2 volts. After this, from V12 and A12, a line generate with the switching of this coil at 2008, and this line goes to the CPU. I will show you. Just copy this line, and next after there is a feedback line. So after in a CPU, a VGPU, because there is in a CPU there is a multiple blocks, or you can say multiple sections, right? A core voltage is a GPU, a GPIU. There is a multiple sections, a modem sections, right? So every section need a requirement to run. So this voltage for the GPU, not GPI, GPU, because your CPU controlling the all over the phone, all ICs working under the your CPU, your processor, your master communicate all over the ICs, right? Control all your phone. Basically, this is the mind. That's why there is a multiple sections, multiple blocks. On each block side, a multiple balls. So in this line, you will get same 0.6 to 1.2 voltage. Also, some caps connected. If you get a low diode value, suppose some lines, not every line you get a low diode value. Some lines you get 100, some lines you get a 60, some line you get a 150, some lines you get a 20. This kind of diode value. But there is no short. Clear? Most of the technician confused in that section. They thinking this line is short and working on it. Inject the voltage, a 1 volt, a 2 volt, a 3 volt, a 4 volt. But there is no heat. A CPU is sometimes CPU heat up, right? They think CPU is short, but CPU is already gone. A CPU working maximum 1.8 volt. If you give it to the 4 volt, how he will survive? There is no logic. There is no V system line. It is no V system or VPH line. So you can apply a 3 volt or 4 volt. Now there is a system. I am sometime apply a 7 volt in a phone, but there is a process to apply 7 volt. I did not reveal in this video what is the process. So 7 volt, when you inject the 7 volt, you will remove the short. So let's talk about this. This is a GPU line, right? How do you check what are the voltage you get in this line? Clear? Now for this, we go to the diagram. Clear this? Right? Now another supply comes in, a V system line, or 3.7 to 4.2 voltage. After this, another voltage create. We made already a VGPU line, right? So in this line, voltage for GPU 0.6 to 1.2 volt. Voltage for GPU block. There is a multiple block on your CPU, like your basement for the network section. Core voltages, modems, VPU, GPIU for the protocols, every section. Now let's go to the another line. This video is already lengthy, so make it fast. Now go to the Borneo again. Now after that, VDRAM, right? Voltage for RAM. I will explain to you. First, there is an input voltage for RAM, not RAM. In a power IC, to create a voltage for the RAM. After that, this IC switching with this coil at 2009 and create a voltage for the RAM. Now, where is this coil? So this, our second coil, right? Now, let's get back to the schematic and follow this line. Next, our feedback lines. This line goes to the U4401. Now, what is this? I will show you in a layout. Go to the layout and search it manually, U4401. This is our eMMC IC, our memory IC. Now, get back to the schematics. Now, next, right, voltage for LPDDR, RAM voltages. Now, after this line connected multiple balls in MMC, connected with the CPU. After this line goes back to the power. So, let me explain to you first I will show you in a bitmap, after make a diagram. After I will explain to you. Now, our second coil, we will see our second coil, remember this coil. Now, there is an input for this coil. After the switching, you will see. Now, this line also connected multiple balls in a, you can say, call eMMC or UFS, whatever you call, but half portion inbuilt in a RAM. There is a two kind of portion in this chip. First, ROM. Second, RAM. You know the difference? You will see this line connected also to the CPU, right? Also, some capacitors on this line. Also, this line connected to the power IC. Now, let's draw it. After I will explain to you. Now, in this diagram, there is a less space, so I will not draw eMMC or so. In this line, I will explain to you with the normal drawing. So, there is an input from another voltage 3.7 to 4.2. Now, another line generate called VDRAM, right? Directly goes to the CPU, right? Also, this line goes to the eMMC IC, right? Also, the power IC. All these line has a feedback. I am not draw because there is a less space, right? In this line, you get 1.2 voltage for RAM, right? Now, in some phones, you will see a RAM chip in a separate. There is a 3 big ICs, a CPU, a eMMC or UFS, another RAM in latest phones. In some phones, inbuilt on a eMMC IC or UFS IC. In some phones, to the CPU. In some phones, there is a 2-layer CPU. First, when you open the CPU, there is on a front upper side, there is another chip called RAM. After the CPU, you will see in a Samsung phones, in a OnePlus phones, also some kind of Xiaomi, Redmi phones, or most probably phones, or latest 5G phones, get double layer CPU, we call double decker. There is 2 chips combined together, upper layer or lower layer. Upper layer RAM, lower layer your CPU. Clear? So, in this line, you will get 1.2 voltage, right? This line goes to the CPU, also connected to the power IC, also connected to the RAM, right? So, if RAM does not get this voltage, so RAM does not activate and your phone does not boot properly, I mean to say in a dead condition. So, this voltage is a must check voltage in a dead condition phone. You can check on a capacitors in this line, right? This line also connected to the CPU. If any connectivity lost with the CPU, power IC and the RAM through this line, percept your phone on a dead condition. Here, now let's get back to the schematics again and let's see the remaining lines. For this, get back to the schematics. Clear it. Now, after all these lines, there are two lines remaining called VS1 and VS2. Now, in my earlier videos, you will see I'm talking about higher LDO, right, and a lower LDO. I will explain to you in this video. Clear? So, for VSN1 and VSN2, input voltage. Clear? After this power IC generate with the coil the output voltage. Now just copy this and follow this line. Now next, feedback line, and next this line goes to the again MT6358 block B power IC in a LDO section. From box section, first we are in a box section. Now we go to the same chip in a different block in a LDO section. Got that? Now next, also this line goes to the a LDO, a separate LDO. In this LDO you will see right on depth for camera. For cameras, also get back to the power IC. We just talk about the power IC. Now a question comes in your mind, why this voltage come out from the power IC and get back, or you can say get back to the power IC. Why? We call this line a higher LDO. So first we will draw this line, or I will show you in a bitmap after we draw this line, and after I will explain to you in a diagram in all detail. So clear this and go to the layout section L2006. Remember this coil and in a layout find it near the power IC L2006. So first coil. Now in a main PCB bitmap, where is the first coil? You will see this. Now through input and the output, you will see some capacitors, also a LDO. Also this line get back to the same power IC. There is another LDO for the camera. This LDO, for a reason, this LDO also goes to the, you can say, connectivity to the CPU for enable, and this point connected to the power IC. Now I'm just talking about only the power IC. After another video I will explain to you this LDO. Right? Now let's get back to the diagram. Now there is a less space. I do not made any input. So on the top you will see a VSN1. Right? We call higher LDO. Higher LDO. Right? In this line you get most probably 2 volt, 2.2 or 2 volt. Right? Now this voltage for enable the LDO section. Now power IC generate many LDOs. Shown to you first. Let's clear this and get back to the schematic. Now again copy this, and this line goes to the same power IC. This is the LDO section. We call first we are in a block A in a box section. Now we are in a block B. Now these are the LDOs. In this line you get 2.2 volt or approx 2 volt. We call higher LDO. Now this line comes out from the power IC and get back to the power IC. Why? Power IC produce LDOs, many LDOs, like a buck lines power LCO also produce many LDOs for all these sections, like you will see a 1.8, 2.0, 1.6, 1.2, right? There are many LDOs from 0.6 to 3.0, but from 1.8 to 1.0 volt, all these LDOs produce power IC the help of this voltage called higher LDO VSN1. Now a question comes in your mind, power IC produce this voltage, these all are the LDOs, that's okay, but why this line goes out and come back to the power IC? Power IC create itself and internally. Now power IC create switching here. After the switching in this line, get high ampere, right? Input voltage is 3.7 volt internally. After you will get a 2.0 volt approx, but with the higher ampere, because power IC produce many LDOs, so they need high ampere to produce or run the LDOs. That's why the switching here and power IC generate through higher LDO. These all are the LDOs. I hope you get my point. If this line, if you did not get here voltage or any type of this line open or short, your phone does not work because your power IC not generate any LDOs. So your phone does not boot. Clear? Boot, I'm telling about a boot word. I'm using a boot word. Boot word means when you connect a DC, that doesn't mean it's boot a 5, 10, 20 milliamp. Boot means this phone does not turning on. Clear? After this line, we go to the again Borneo VS2, same input line 3.7 to 4.2 volt. On this line also get back to the power IC feedback line. So same you will see in a power IC B section. Now I'm directly explain to you in a diagram. Now on the lower side another creation, a diagram, a little small diagram from a coil, get power input, and after this line goes back to the PM chip, our power module. This line called a lower LDO. Just like a higher LDO, this line also produce LDOs, a lower LDOs like 0.8, 0.6 under the 1 volt. All LDOs power IC produce the help of this lower LDO. If this line get open, damage or any kind of situation or short, your phone does not work on in that condition. So in this line you will get 1 volt. I hope you get my point. Also, I hope you enjoyed this video and learn something new from this topic. Now this phone had a single power IC. In some phones you get dual power IC or triple power IC or 4 power IC. So don't get be confused. Things are complicated. First, before you do not know the circuit, don't get be afraid. Stay connected with this channel and keep learning. Keep improving your knowledge with new topics. Till then, we will meet in the next video. Take care yourself and your family. And keep learning, keep growing. Bye-bye.